This is IBM Museum, and this will be a short video. I promise. I don't have really that much to cover, but one of the things I do want to cover going in, and I'm just a little bit over 500 subscribers now, so thank you very much to the people that have responded. And I do have a live stream that I plan tomorrow, which is Saturday, August the 21st, 2021, of course, at 2 p.m. Mountain Standard Time. And that's GMT -7 for those that don't really have calculators, time calculators in their head. That would be 4 p.m. Eastern Standard Time, 3 p.m. Central Standard Time, or CST, and 1 p.m. Pacific Mountain Time. It's gonna be Pacific Standard Time. And I don't really know what I'll go through and cover. I'll get turned around and show some of the stuff that have come in, because this is a little bit of an unboxing video. I'm going to be watching the actual chat in that live stream. And again, I'm trying to hold that down to about 45 minutes to an hour. But I'll be watching more for comments to respond to those, because that's what a live stream is, different from these videos. And of course, I'm not able to make YouTube announcements until I get up to that 1,000 subscriber level, like everybody else, but we'll get there one day. And that's why I have to do it in this manner. So I'll go through and I'll get the internal webcam turned off in front of me, get rotated around. And one of the things that I may cover a little bit tomorrow, and I have to pull some stuff out, and I know what this is, and it's not a keyboard, despite the box, and it's not an IBM device, although it does fit in a Microchannel system. So I really am interested in kind of looking that over. And this is a little bit unique. I'll get to that when I cover the live stream tomorrow and go through. It's still sealed up. The other unboxing I'm going to do, and I did go through and of course pull these out of the packet, and I've got it flipped around, pull tab to open. This has got so much tape for this repurposed cardboard that I don't know where that tab is, and I pulled these out of the bubble wrap, and for the purposes, and the 3 cards were separated. In fact, this one is still in plastic, but it did have bubble wrap between them. We'll get those organized off to the side and get the bubble wrap back on the back, and we'll do a view like that of the first adapter before I actually go through and flip to the camcorder view. And I'll have the ability to go through and see, being turned around like this, to see what I have up on the screen and I'm presenting, and also the ability to zoom in, because we will go through and zoom in. And this is the first listing, and the seller had several of these up. And of course, you'll recognize that it's a prototyping board, just like I've featured for the ISA models before. And I still have to locate my Microchannel prototyping board that has some chips over here, and that's mainly for the adapter ID decoding, and just some basic bus attachment chips that interface to the Microchannel bus and give you some access to signals that just about any Microchannel board would do out there. And I'd love to say that this is Microchannel. I mean, it looks like 16-bit from a distance. It looks like 16-bit Microchannel with an AVE extension on there, the auxiliary video extension. And you know, I don't really have any links on this video. It might be good for me to kind of probably I can do a link on the Ardent Tool microchannel bus connectors. Again, that's what I'll do. And I might even pause the video and get that up and just briefly go over that. Still trying to keep a short video. Let me get zoomed on this one. I'll zoom out for the other ones, of course. And you know, this looks like that 16-bit, like I'm saying. The other two are, and these are from the same seller, and they are 32-bit microchannel, and they both have spots on the board for breakout connectors and things like that on this back row. And those pins could probably even be, they're probably even offset a little bit, so you could put a DB style connector even up to like a DB37. But I'll get to those in a moment. I want to get zoomed in. Okay, so we can see that's an IBM part. Even gives the part number 60F1194, and it's got a phone number, and this is in kind of south central New York State of 607 755 6566. And I looked over that area code district. I didn't really know right off the top of my head of what IBM facilities would be in there or what may have produced this PCB, printed circuit board, because this, as you get zooming in, this is kind of unusual in a way for Microchannel. And you can see that it says the pin side A, which is reversed from what Microchannel would normally do. And it has those bus connections, you know, the trace that goes all the way around the board, that are labeled as 5-volt ground and 3.3 volts. And 3.3 volts kind of gives it away rather quickly, in that and besides being the pin side basically being on the wrong effective side. Let's see, yeah, and this is listed as the component side. Oh, and there's even notice it for the first time, IBM, nice little logo in there. And again, it's got the markings for those voltage and ground rails that go around the board. Handy to have those. But this is actually a PCI connection, and this is by the connections on either side of the main bus connection. This is actually a 3.3 volt and 5 volt PCI adapter. And you know, different from like the later PCI 3.3 volts, where it would have had a, you know, the in connector off here. And this is it's wider than what you'd have for the AVE connection anyway. This bus is off from what Microchannel would be. In fact, kind of getting into it, this is good because it doesn't reveal much. But we can see, you know, a legit Microchannel, 16-bit Microchannel adapter there. And that front bit lines up real good. It's the right number. But look at that back area. And this is in the 8-bit Microchannel area. That would just mess that up entirely. And it's probably where these rails are maybe tied into the appropriate pins here too, is what I would expect. There's probably a ground and voltage plane that might be in that PCB, and of course, edge on, I can't really get a focus on it. And you can see maybe in the background here, you can see that there's an inner plane that they put for a ground plane, and that helps to cut down the electromagnetic signals and things like that. Acts as a little bit of a shield. But I'll bet that those power rails and ground plane ground rails are tied into the appropriate connections. And I told the seller, that I'm happy with it. It doesn't really matter too much. The seller even has, and that's remarkable for the IBM side. I have exposure to the ESIA bus, that standard industry standard architecture bus with all the upper and lower pins, and the seller does have some of those. And I don't know what kind of buyers he has for those, because I don't know. There's people out there that are making sound cards and other devices for the Microchannel bus, but I don't know of anybody that's doing anything on the ESIA bus, just mainly because it's an expansion of ISA, and it's more of a challenge because ESIA, just like PCI and Microchannel, I mean, it's a numerated bus, and you have to have identifiers on. Plain old vanilla ISA, you don't. You just work with the signals. And of course, it should be remembered in that previous video that I had of where I went through, and I do have the ISA prototype boards that I did for that. And so who knows? You couldn't go through and chop this down, that connector, to make it into anything like Microchannel would expect. But it's nice having it around for that IBM marking and being an IBM product. Just kind of strange that it was for the PCI development side and voltages. So let's get that on the back row there, and go on to these, and I'll just briefly go over. I can zoom out, and it's, these things are shiny, they'll pick up the ring light and everything, but there's the 32-bit Microchannel bus, real nice there. And that's, this is appropriately the component side of the board. I'll show you the comparable adapter that I had up in a moment, with that being 16-bit, but it's got that all that ground stuff, and then of course has plate throughs. And this would be more like for a wire wrap typically style, where you'd go through and you'd put just the sockets down, and those little holes being independent of that, and you don't even go through and you don't even solder them. You do the just put the socket through and wire wrap it on the other side. And I showed my wire wrapped postcard that you get the for the XT bus, that you go through and you plug in, and you get the post codes that the system throws off at startup. And I show that that's a wire wrap design. But Mark says, oh, that's the plus 5 volt. And this is probably the ground side. And that being, focus. Okay. Yeah, solder side. Like I say, even though it may not necessarily be solder, but then that's the ground side. And 5 volt and ground being the voltages for the Microchannel bus. That's what gave away this other IBM adapter a little bit is those markings of the 3.3 volt. And like I say, with it zoomed in now, you can kind of see the, it looks straight on. I don't know if, okay, yeah, the outer connection's not, but this is actually interleaved for like a DB style connector here on those pinouts. And even on the smaller side for that, it's got the, for like a DB. And we'll have to see how this one shows up with it still having some plastic wrap on the outside. And I don't know if this is anything original for the manufacturer, but this one having, not necessarily having those big ground and power planes there, but having the power rails that go around the outside, like we saw on that other adapter. And then the connection here of the DB style or offset connectors that could have put in there. And I don't think this is labeled for anything like the component side or the wiring side, SAR side, anything like that. Not really marked much for the branding of what the board, who produced it, maybe quality assurance up here, but not really many markings. And that straight copper traces, they're not tinned like they are for the other adapter that I have here. So those are kind of what I wanted to bring out. I'm still waiting for, I was surprised, I found a couple nice brochures that were on some Microchannel boards, and I'm waiting for those to come in still, but I've got the other parts that came in, and I'll probably be talking about these at some point in the future for the prototyping that I'll be doing here. And I have a few of this style board, and then I've got an older one that I'll pull out as well. But you say prototyping, that seems like it's kind of pretty developed, has components everywhere. And these are from Cumulus, and they call this the 16 Plus, the CU-RAM 16 Plus, so we can see that silkscreen identifier. And what I'm referring to in particular is that there's these headers in here. This header, and then it's got a header here, a header over here, and a header over here. These aren't really marked as necessarily as jumpers necessarily. But this is actually for an optional, and the brochure I have is just about the same focus of this 16 Plus card. And then there's another brochure page, and I'll show them on video and go over these adapters a little bit more when they come in. But it shows this area and Texas Instrument chips there in that area for running the RAM side of things, because the major function of this board is the memory expansion. And I think this is a really nice one. This is actually kind of a Model 50 and 50Z ideal adapter, because it's 16-bit in the first place, and it actually has 12 30-pin SIM slots, and this is able to handle the 1 megabyte standard SIM. So you could go through, and eventually you could ultimately have 12 megabyte on this board. And for the limited amount that you can have on like the 50 and the 50Z, the Model 60 is the same way, but that's a tower system, so you've got more microchannel slots. I'm saying on the 50 and 50Z, you're limited to 3 16-bit microchannel slots otherwise for expansion. And you can have, with the 50 and 50Z, you can have ultimately up to about 2 megabytes on the planar as planar memory. And so you need an adapter if you're going to go anything above that. And this is really nice. So it has the ability to add on 12 megabyte, even at 0 weight states effectively for the 50Z. This will work very well, and I'll probably go through and get these units positioned on that. But these back headers here are for an IO daughter card that connected on there, and it gave one serial port and one parallel port for all those, tying into all those pins. It's a daughter card that was over the top. You could disconnect that back bracket and have the pinouts for that. And so I'm going to try and go through and replicate that, you know, to go through and kind of reverse engineer, figure out what the pinouts of this big connector is, what power, these 3 pins are probably power. And I'm going to match a little bit of the Texas Instrument sort of thing with the chip I'm going to do it with. And I'm just going to go through because this is nice. It's all in one package. And these are, in fact, I can get zoomed in. So that's a 16C451. And this is ultimately on this chip. This is one serial port or a UART and one parallel port. And some of these designs, like I think this one is on like the model 3026 and model 2526 planers for that single serial port and that single parallel port. And these are socket. These don't have what they call 50 UART, which is first in, first out, FIFO. And that's just a buffer for serial communications. The 16C551 does have a UART with the 16 byte 50 buffer. And I'm going to, of course, when I prototype things, I'm going to make I'm going to get a socket where this, wherever this ends up on the board. I'll have to see if I maybe even do it reverse, where it kind of nestles down, the socket being on the underside for that daughter card. I'll just have to determine how much room I have on that and fit it in otherwise. But using that to give the support of the serial port and the parallel port. And then if you want to go to the 16C551, you just, you know, put the appropriate one in the socket, the replacement chip from this one. And I do have I ordered and went through, and I got these at a real affordable price. I went through and each five to each holder and dumped them out the end. And they're all the TI chips. I'm pretty certain that, you know, these are not rebadged in any, you know, or remarked anyway from like Chinese sellers. It's got that nice inset on the underside of Philippines. All those match up. You know, somebody could go through and they could maybe wipe that and sand it down. They'd have to get rid of the the kind of the dips in that top covering to maybe try and remark that as a, I don't think they'd mark it as a 286. I think they'd probably try and market it as a 387 SX or 387 SL chip because it's that same 100 pin PLCC package, plastic leaded chip carrier, not leaded. Well, plastic leaded chip carrier. Excuse me, not leaded, leaded. And so that'll be a future thing I'll look at. This is the older version, and I don't have the 32-bit version that I have I'm getting the brochure with for. And I haven't seen any of these things in the wild of these IO daughter cards. But that's the older adapter, and it actually had kind of the Model 80 style memory daughter cards. And I've got pictures of what those daughter cards look like. And there's even a 32-bit adapter that does the same sort of memory daughter cards. And then this last position here is for that I/O daughter card in here. So I got this as well, just being the older version. But that I/O daughter card's the same thing on that. So that'll be a future project. As I went over the 46s, the processors, I did move this one around on the screen, but I didn't. This is another possible idea for a later video, although it's been kind of done to death as it is. But the 46 CPU I have here, I've got penciled in as dead. I mean, I went through and tested this thing, and it's in good shape otherwise, but didn't respond. And so what I made to go through is I may go through and delid this, pull that cover off the bottom. And I've got USB microscopes. Nothing real fancy. Doesn't go through to the same point of the, like that micrographia video there, linked in that to kind of where they went over the 46SX to look through that. But that might be an idea for some later video, just some time of looking inside that to kind of see how that is. But let's go through, and I mean, we need to have a shorter video that's for once. And we're going to get below a half hour, which is great. I wanted it originally to be closer to 15-20 minutes. And I do have to see how the system's doing. I got the fan blowing here, but I've turned all the coolers otherwise off and for the noise, and closed the windows. But it is getting steamy in here, so it's good that the recording is short. If you did enjoy this content, click on that like button. And by all means, subscribe to my channel. I'm still encouraging that. Even though I'm over 500 subscribers, I'm more than halfway there to where I want to be for that starting number of 1,000 subscribers, so I can go through and make the YouTube announcements. So recommend the channel to your friends as well. This time around, I'm not doing the link of 5 channels that I'm trying to promote as well to get up above that 1,000 subscriber listing, but likely in the next video, I doubt in the live stream whether I'll do it, but who knows. If you are a YouTube content creator, in particular if you're in the retro side, and you can have other videos in there mixed in, but in the retro side, please try to make the live stream, because you can go through and throw in your channel name, and you know, we'll go through on the fly and just evaluate it, and kind of where I can go through and put it out as a recommendation. There's be other people in there that they may want to look for those retro channels as well. So that might be a good point. And again, I'm going to provide the time for that. That's going to be 2 p.m. Mountain Standard Time, 4 p.m. Eastern Standard Time, 3 p.m. Central Standard Time, and 1 p.m. Pacific Standard Time. Elsewhere in the world, I don't know what, schedule's the easy way to explain time, but the Mountain Standard Time of, 2 p.m. Mountain Standard Time, that is the GMT -7 time zone. So you could probably find out the scheduling otherwise. And it's a little bit later, so I can go through, and maybe the people on the West Coast want to participate. I've already had Major Tom say I just can't make it. I've got other obligations. So we're going to kind of adjust the time frame and see how that works. But that's all I have for now. This is IBM Museum. Thank you.